Have you ever stopped and wondered what is actually going on inside the mind of an AI? We give them these huge, complicated jobs, but what about the really simple stuff? How does an AI even begin to think? Well, today, we're going to crack open that black box. We're using some incredible research to figure out how an AI handles one of the most basic commands imaginable. And trust me, the answer is way more surprising than you'd think.
It seems almost silly, right? Super simple. But for an AI, this isn't just about knowing what a fruit is. It's about how it actually processes that command. How does it turn our simple little request into a real search and find mission inside its own digital brain? That is the exact mystery we are solving today.
So, to get to the bottom of this, researchers gave a large language model a really straightforward task. Take a look at this list. Cherry, knife, pants, ambulance. The prompt was dead simple. Find the fruit. And yeah, of course, the AI gets it right. It picks cherry. But the real question, the multi-million-dollar question, is how? How did it ignore everything else and just zero in on that one word?
To find the answer, we have to actually look inside the AI's mind. For the longest time, we've thought of this as a black box, right? We know what goes in, we know what comes out, but the middle part? Total mystery. But now, researchers have come up with this super clever technique that's kind of like performing virtual brain surgery on these models.
This method is called activation patching. Let me break it down for you. While the AI is doing one job, let's say, find a fruit, the researchers can pinpoint the exact part of its network that's handling that "is this a fruit" logic. Then, and this is the brilliant part, they can copy that little snippet of thought and paste it into a totally different task. It's an amazing way to figure out what all the different bits and pieces of the AI are actually responsible for. And this slide right here, this is the big aha moment. Okay, let's walk through it. Look at the top row, the source run. The AI is told, find the fruit, and yep, it focuses on the cherry. Makes sense. Next, the destination run. It's told, find the vehicle, and it correctly focuses on the ambulance. Easy enough. But now for the magic. In that last patched run, the researchers pasted the find fruit thought into the vehicle task. And look what happens. Even though its main goal is to find a vehicle, it completely ignores the ambulance and locks onto the cherry. This is the proof. They actually found a portable, reusable command for find a fruitness.
So, what do you call these little specialized parts that carry these portable instructions? The researchers came up with a great name for them: filter heads. And it turns out these little guys are the AI's internal toolkit for solving these kinds of problems.
So what are they, really? Well, these filter heads are basically parts of the AI that decide what information is important. And they've learned how to create a general rule. They don't just memorize that a cherry is a fruit. No, they encode the abstract idea of fruitness into a little reusable instruction. And that instruction can be used to filter any list of items to find whatever matches that rule.
And they aren't just scattered all over the place either. The research found that these super important filter heads are all clustered together, mostly in the middle layers of the AI's architecture. You can almost think of it like a dedicated central processing unit, but just for filtering tasks.
So, you might be wondering, just how critical are they? Well, the researchers tested that by basically just turning them off. It's called an ablation study. And the result, as you can see on this chart, is just staggering. When the filter heads are working, the AI has perfect accuracy. But when they're gone, its performance just tanks, dropping all the way to about 22% accuracy. This proves they're not just one way the AI solves the problem, they are the primary way.
But here's where the story takes another fascinating turn. It turns out the AI is even cleverer than we thought. It's not a one-trick pony. It actually has a backup strategy, and which one it uses all depends on one very simple little change.
It all comes down to the order it gets the information. So look at the left side here. If the AI sees the list of items first and then gets the question, it uses what the researchers call a lazy strategy. It basically just waits till the end and then uses its filter heads to do the search. But check out the right side. If it gets the question first, find the fruit, and then it sees the list, it switches to an eager strategy. As it goes through each item, it immediately checks if it's a fruit and attaches a little mental "is a match" flag to it. So at the end, it just has to look for the thing it already flagged. Pretty clever, right? Two totally different approaches to the same problem.
Okay, so we've peeked inside the black box. We found these incredible, specialized parts and these different strategies. But what does it all mean? Why should we care about any of this?
This quote from the research paper really just nails it.
What it's saying is that the AI, with zero explicit instructions, is spontaneously coming up with computational strategies, like lazy versus eager evaluation, that look almost exactly like fundamental concepts from programming languages that humans designed. It's basically inventing elegant solutions all by itself.
And these filter heads aren't some fragile one-off trick. They are incredibly robust. I mean, they work whether the list is in English or Spanish or French. They work if it's a single line of text or a bulleted list. And the concept isn't just for fruits. They can build these filters for professions, landmarks, you name it. This is huge because it proves they're working with abstract meaning, not just memorizing surface-level patterns.
And this discovery leads to some seriously cool applications. For instance, you could build a concept detector without any new training at all. You just give the AI a prompt, say, find the vehicle. Then you pull out that little vehicleness concept from the filter head. And bam, you now have a probe you can use to scan any other document to instantly find mentions of vehicles. It's a powerful tool you can create on the fly.
So if you take one thing away from all of this, let it be this. Large language models are doing so much more than just being brilliant parrots. They are actively building their own internal toolkits, creating abstract, reusable, and surprisingly sophisticated computational methods to get things done.
And that, of course, leaves us with a final, pretty mind-bending question. I mean, we humans spent decades developing programming ideas like lazy and eager evaluation. If AIs are already stumbling upon these same core principles all on their own, what completely new, maybe even alien computational concepts are they going to invent next? It's a pretty wild thought to end on.